So the American chestnut used to be one of the most common trees in the forest in the east, and representing about 1 out of every 4 trees. It's kind of hard to believe, but there was that many. Somewhere between 3 to 5 billion of those throughout the Appalachian Mountains. And it was a major food crop for the wildlife. It would produce very abundant nuts and very consistently year after year. So a lot of wildlife depended on that to fatten up for the winter. And why we don't have chestnut today? Well, as people started importing Asian chestnuts, mainly just to plant out in their yards and in orchards, they inadvertently brought over a blight with it. And that blight in Asia doesn't cause too much problem because the trees there co-evolved with that pathogen. But here, the American chestnut never saw the blight and was very susceptible to it. And so it was introduced and first described down in New York City at the Bronx Zoo, and from there quickly spread throughout the range and killed basically all the mature chestnut trees from Maine all the way down to Georgia. And so we don't have those trees today. Now, they're not extinct, they're surviving at the roots right now, and but every time they try to spring up from the roots with shoot sprouts, they get the blight again, get killed onto the ground. So we're stuck in this cycle of growing a little bit, getting killed to the ground, growing a little bit, getting killed onto the ground. So that's the reason why we have worked on this project, to try to make a blight-resistant chestnut tree.
We divided it up 23 years ago with, he would develop a list of genes that he wanted to put in, and I would develop the technique to put them in and regenerate whole plants from those transgenic cells. So that's pretty much the way it's worked out. Is he's got a whole deep freeze, ultra low, full of genes to test, and we've now developed, after a lot of head banging to get it done, but we've now developed a technique for putting those genes into chestnut, into single cells of in the somatic embryos of chestnut, and then regenerating whole plants.
Let's talk about, it took a long time to get this process developed. And what I like to say is that we had to build a boat before we went fishing. So the first 16 years or so was building the boat, and now we're fishing. And we actually got a big fish on the line right now, and that is a certain gene that seems to enhance blight resistance very well. It actually comes from wheat, so it's a gene that people eat all the time. And it actually gives the plant a shield against the fungus. It doesn't actually kill the fungus, it protects it by detoxifying an acid that the fungus produces. So the acid this fungus produces actually will inhibit lignification and will kill the plant cells, allowing the fungus to invade and basically girdle a tree, form what's called canker. So what we're doing is giving it an enzyme, an enzyme that degrades that acid and therefore protects it, and therefore the tree can heal and continue to grow. What we're doing right now is we're starting to pick what we call lead events, and these are the ones that we want to take through the regulatory process. We have to submit applications to the USDA, who's has the main oversight right now. Then we'll have to do EPA, and then also the FDA. And each one of those organizations, government organizations, will have to approve before we can actually have these things released as a non-regulated plant. So that's what we're starting at right now. We actually are doing certain types of studies to put together a petition that we'll submit to them showing that these trees are safe. We're doing things like looking at mycorrhizae colonization. We've actually completed that study where these are the beneficial fungi that associate with the roots of the trees. And we found that there's no difference between our trees and wild type. We're looking at insect feeding. All the first studies with that showed no difference, and we're still continuing those studies. We're looking at leaf litter decomposition, and those are ongoing. We're looking at nut composition to make sure the nuts haven't changed because of the gene we added. We don't think it will, but we're checking, and we're going to have those results pretty soon too. So we're getting all this ready so we can submit this application because, like I say, it takes us several years to go through this whole process, and we want to get these trees out to the public as soon as possible.
I think it'd be highly marketed around here because they did very well around here. Very productive tree here. It's not necessarily a tree you want on your front yard though, because of the husks, the fruit, or the husks of the nut are extremely sharp and spiny. So although they do produce really large, very edible nuts, it's not something you really want on your front yard. I think the general public doesn't have any idea about the chestnut and how important it was in the past, ecologically speaking. It was like one of the greatest ecological disasters in the history of the world, because it was such an important and common tree in the eastern United States. It changed the face of the eastern United States and almost all its forests. And I think a lot of people don't know that, the significance of it. I think the general public doesn't have any idea about the chestnut and how important it was in the past, ecologically speaking. It was like one of the greatest ecological disasters in the history of the world, because it was such an important and common tree in the eastern United States. It changed the face of the eastern United States and almost all its forests. And I think a lot of people don't know that, the significance of it.